All right, in this video, we are going to talk about how to use these trigonometric ratios in applied problems, real world problems. So, before we go into an example, we need to talk about the angle of elevation and angle of depression. The angle of elevation would be if you're looking up at something, right? From a position like, for instance, imagine somebody's standing here looking at the very top of this tower right here. So the angle of elevation would be the angle that's made from horizontal, right? So in this case, like the ground level, right, to the line of sight up to the top of the tower there. All right, so that would be the angle of elevation. So the angle from horizontal to the line of sight from the person's eye, right, up to, or from wherever could be a measuring device or something, right? But the angle from the horizontal up to the line of sight from up to the top of the whatever it is that's being measured. Okay, so that's the angle of elevation. The angle of depression is sort of the opposite of that in a sense, right? So that would be from if you're, say, at the top of this tower looking down, right, to a certain point. So again, that would be the angle from horizontal, right, wherever the top of it is. So you're up looking down, and then that's down, the angle made from the horizontal down to the line of sight from the top of whatever it is down to a lower point. Okay, so that's what's meant by the angle of depression. All right, so let's work through this problem. It says a hiker is standing on the ground looking up to the top of a tree with an angle of elevation of 25 degrees. The distance from the hiker's eye to the top of the tree is 61 feet. What is the distance from the hiker to the base of the tree? Round to the nearest whole number. Okay. All right, so here is a great drawing of the situation, right? And so the angle of elevation, right, would be this angle from, it says from the hiker's eye, right? So that would be from the horizontal, right, up to the top of the tree. That's 25 degrees, okay? All right, and so what you can do then is to make a triangle out of this, and so what let's go back over what they tell us. They say the distance from the hiker's eye to the top of the tree is 61 feet, right? So that would be this part of the triangle right here, or this distance right here is 61. Okay. And what they want to know is what is the distance from the hiker to the base of the tree, right? So that would be if we dropped a perpendicular down here, made a right angle, right? We would want to know what is this distance here. So I'm going to call that distance D. Okay. So let's see if we can redraw this a little bit bigger here. So now just looking at the triangle, right, what we've got is a right triangle with distance D here that we're trying to determine, right? And we know this side over here of the triangle, so 61, okay? And so we want to find D. Okay, so we can do that, right, with using the trigonometric ratios, right? So looking at this angle 25 degrees right here, we look at the side that we know, which would be the hypotenuse, right, of the triangle, since it's opposite the 90-degree angle. And this side D here for the angle 25 degrees would be the adjacent side. So we've got the adjacent side to 25 degrees, we've got the hypotenuse. So what we would do is think about what trig function would we use that relates the adjacent and the hypotenuse, and that would be the cosine, right? So the cosine of 25 degrees is equal to the adjacent side, which is d, over the hypotenuse. So d over 61. All right, and we want to solve for d. We can do that by multiplying both sides by 61. All right, and then cancel out the 61s over on the right-hand side. All right, and we've solved for d here. All right, and so then what we would do is just go to the calculator. All right, and just make sure that you are in degree mode, since the angle is specified in degrees here. And we can see we are in degree mode here, so you would need to check that on your calculator. And then now you can just enter that in, 61 cosine of 25 degrees. And that comes out to be 55.28, right? So what that means is that the distance, right, is approximately 55, right? To the nearest whole number is what they wanted, okay? And this is an applied problem. They specify the units, right, as being feet, right? And so don't forget your units there. So 55 feet on the height of the triangle. All right, and that is it on this one.